Okay. To find the area of a composite figure, divide up the regions and find each area. Then find the sum of the areas. Yanni, I did tell you. So for example, number 1, find the area of each figure below, round to the nearest. We're not doing the hundredths, we're doing the tenth. We're always doing tenths, please. When necessary. So for number 1, they've already sectioned it off, okay? So if you notice, they've got this right here is your rectangle, and this right here is your trapezoid. Okay, so now it's actually doable. So you do an area of your rectangle plus your area of your trapezoid. So you do the area of the rectangle plus the area of the trap is going to give you the area of the entire figure. So the area of the rectangle is going to be 23 times 12. The area of the trapezoid is going to be 15 plus
What plus is times
23 base plus height, base 1 plus base 2, trapezoid.
Height. Wait, what?
I'm doing the bases, right? Just doing the bases. We're going to do the height. We're going to divide it by 2.
Where's the height?
So if this whole thing is 18, and that's 12, what is this?
6.
There you go. Good question? Okay. I just kind of did it backwards. Sorry.
No, I just thought it.
So right here, you could reduce the 2 and the 6. That would give you 3. Just to make it easier. What's 23 times 12? 276, is that right? Yeah. And then 15 and 23 is 38 times the 3. So 276 plus 114. Which equals 390, I think is what you said.
Yep.
And that's centimeters squared. Let's look at number 2. Look at number 2. If you look at number 2, you've got this half circle, right? You got this half circle, which makes a
360 degrees.
okay. So because you have 2 half circles there, you have to figure out the area of the circle. For this, we have the area of a is it a rectangle or a trap? Actually, we go the entire thing. We get no, we go all the way across. We get a rectangle there.
No. it's a parallelogram.
Well, parallelogram. You get a parallelogram. So and then add those together. Okay, when you do those, you add those together and you're going to get 173.1
How do you do that?
inches squared. What's your radius here? 6. What's your height of the
12.
one of the sides would be 12. You know, what's the base? 5.
Oh, yes.
And this could be 12. Okay. Whoops. For this one right here, for number 3, you've got 3 areas. Okay. Here's one of them. Here's another one.
Is there like a where is it?
The area of a triangle, area of a rectangle, and a half of a circle. And add them all up. For number 4, you've got a half circle. And you've got a triangle. Number 3, the answer is 325.2 feet squared. Number 4 is 220.5 meters squared.
Are you going over those right now?
I wasn't going to.
Okay, but how do you find the height? It's 26 in total,
Mm-hmm.
so how would you find the height?
So if this whole thing is 26, this is 7. That cuts that off at 7. What's this right here? Like this rest. Okay, so that's 19. And then, okay, so let me get rid of that for a second.
So do you just do like a half circle?
Hold on. Okay, so I took that away, right? So this 9 right here is also this right here. Whoops, didn't want to do that. Hold on. This right here is also 9. Isn't that the radius? Okay, so if that's the radius, this part right here is also 9. Right? Are you with me? So if that's 9, right here is 9. Right here is 7.
Okay, I get it.
What's that part? Write it down. What's wrong there? Nope, what's wrong? Do I need to erase? So again, pull that off. If this whole thing right here is 26 from top to bottom, okay? This right here is 9. So is this right here. That's 9 also. Okay? What did I just, what is that called?
Rectangle.
This right here is called a radius. So is that. That's also a radius. Well, from here to there is 9. Well, because from this right here is 9. That's a radius. That's got to be 9. It's a radius. And then from here to there is 7. Why don't you look up before you, because you're missing it. Exactly. Look up. Don't look down. From there to there is 7. Don't look down. Which means from right here to right there is 7. So what is it from right there to there? 10. Which means that is right here. Is that 10? So it's a great question, you know. And if this is 9, what's this? 9. So you have your base and height. Right.
Wait, I don't get
Go ahead
how to get
from the top. From up here. Okay.
So, for the triangle, would it be 9 times 10 divided by 2?
Yep. It's the formula. Okay, so for this one, again, you just need to go through and figure out. You need to figure out this guy. How would you figure that out? Pythagorean theorem. If you can figure that out, okay, knowing this and all 4 corners are right angle, what kind of a figure is this? Square, which means this is congruent to these two. So if you know this, it's going to be the same over here. Add them together, you'll get this. It does really all fall out as long as you guys know your properties. Okay. Shaded regions, which is something we already did. To find the area of a shaded region, find the area of what? What do they have written down? Yeah, entire. Ew. I would have put the bigger one. Yep. Entire figure and then subtract. So for this one, for shaded regions, okay, you always want to take the area of the big and subtract out the area of the small. Okay? That's going to give you the area of the shaded. So for this one, you're going to do the area of the square minus the area of the circle. And if this whole thing is 25 up here, which is your diameter, what's half of that? So your radius is going to be 12.5. Your diameter. This is your diameter. It's the same, right? Yes or no? Okay, good. This one, you're going to take your area of your rectangle and subtract out your area of your triangle, and that'll give you your answer. And if this whole thing is 25, then this whole thing has to be, you already have your height. Half of it. That's why I'm flying through this part. Okay? That's the only reason. I promise it won't. Okay. This one right here, no matter what you do, you have to take half of the circle. Okay? So you're going to do the area of a circle, but you're going to take half of it. And then you're going to subtract out the area of the triangle. Okay? Because it's only half of it's a semicircle. Now, with this one, do we have the height of the triangle? No, we don't. So we need to drop the height. There we go. Drop the height. Okay. Which gives us 90-degree angle. Oh,
Why can't you just Pythagorean theorem to just find the base of the, to find the diameter of the
Oh.
circle?
why would you do that?
Why can't you?
I'm asking. Why would you?
Because it's your right triangle.
Why do you know that? She's right,
This
but
is tangent or whatever.
no, it's tangent. No,
Did you even see that?
I just saw it when she saw it, when she said it. I had to back up. No, there's a reason. If it was a full circle, I would have seen it quicker, but
There's a, I don't know, corner or something.
what kind of angle is it?
Right triangle.
What kind of angle is this called? It's an inscribed angle. Because it's right here. It's touching the circle, right? It's called an inscribed angle. Okay? And if it was I'm going to do this. I'm going to try. Not bad. If it was like that, would that help you give you a reason why it's a 90 degrees now? Why? No? Shake your head, yes. What does it cut off at? What is it?
180.
At the center, but it's also, which it means it's a 180. Remember what inscribed angles are? 1/2 of the arc. This arc right here is 180 because this is your diameter. That guy's your diameter. That's your diameter. So then you can do your Pythagorean theorem that way and get your diameter. It comes out as 23.4. So your diameter, just gonna help you out here. So your radius is 11.7. Okay? Yes. Already have them. Enter base because it's a right angle, right triangle. I can't turn the actual page, so I'm sorry. And then what kind of figure is 9? The bigger figure. Trapezoid. So you're going to do the area of the trap minus the area of grow up of the semicircle. Okay, area of the semicircle.
Is that half a circle?
Mm-hmm. Now, how do you find the height? You got to drop this down. And if that's 17 and this whole thing is 37, then what's this? Now you can do your Pythagorean theorem again. Okay? Hmm? 15. Mm,
So did we just finish half? Is that 20?
should be 20, yeah. That is one section. Now I'm getting tired. It's not good.
You're getting tired?
This arm carrying it. The distance from the center of the polygon to any side is called the apothem. We like to be silly. I know you guys don't care,
Awesome.
but opossum. Yep.
Not funny.
Sorry. You'll get over it. Make sure I spell it right though. The distance, wait, sorry. The radius of the regular polygon is the distance from the center to the vertex. So it's really, really important for you guys to see that off to the right here, this is your radius, and this guy right here is your opossum. And the reason why is because the radius has got to go from the center to the edge of a circle, okay? And the dotted line around is the circle, but we don't draw it. That's why it's dotted. Okay, so it's like the figure that we're looking at is embedded in the circle, but we don't draw the circle. Okay, and then the apothem, awesome, is the one that only goes to the actual figure we're looking for. It doesn't go to the actual circle. Okay, so, and I'm gonna tell you right now, you're gonna be using, you can write this off, let's write it underneath the area of a regular polygon. You're gonna be using your 30, 60, 90, 45, 45, 90 formulas. What are those? Oh, look at that, right below. How exciting. So, the other formula that you need to remember is on the step number 2, okay, the measure of the interior angles, the sum of them, which is n minus 2 times 180, okay? When you figure that out, you are then, once you figure that out, you would then take that answer and you divide it by 2. So what happens here is when you do the sum of the interior angles, you're finding this right here. Please look up. You're finding this entire angle right there, okay, for the entire triangle. By dividing by 2, you're getting that angle. So the sum of the interior angles, n minus 2 times 180, is this entire angle. When you divide it by 2, you're just getting half of the triangle. And that you have to do every single time. Excuse me. Okay? And it's literally a quick step. It's not very difficult. Okay? It's really, really, truly not very difficult. So, what is n usually in all these figures? What does it say? What is usually n, guys? What?
Outside.
Thank you. Sides are, n is usually represented by sides. How many sides there are? Write it down. How many sides are the figure? In a triangle, how many sides? That's your end. That would be for a triangle. How many sides in a square? That's your end. Okay. So for number 1 and 2, find the area of each regular polygon. Okay. So again, I'm going to say this to you guys again. You have to write the formula down. So we have the apothem. From this, we draw our okay, from that we draw our radius, okay? All these sides are the same. So because this is 24.2, this entire thing is 24.2. It's a side of the triangle. It's a regular polygon. Regular polygon means that all sides are congruent. Okay. Because we only want half of it, we only want this half, how do we figure out what that is? Yep. Both of you, good job. 24.2 divided by 2 is what? Good. Yeah, 12.1. So this right here is 12.1. So what do we have? We have the apothem. Okay. Do we need the radius? No, we don't really need it. Why? We just need the apothem and the perimeter. Please look at the formula, guys. Please look at the formula. You write down the formula. Area is equal to apothem times the perimeter over 2. I guess maybe we should have written that. I written that up there. We need the apothem and we need the perimeter. So was it necessary for me to actually take the side and divide it by 2? No, but it will be handy later for you guys to do that. Okay. How do we find the perimeter? Add up all the sides. Okay. Or we can do the side times 3. So let's do that. Perimeter is equal to 3 times 24.2, which is what? What is it? 72.6. Perfect. Perfect. So, and I don't know if you guys remember this, and if you don't, please listen to me now about it. Do not hit clear on your calculators. Just leave it there on your screen. There's no reason to. Okay? No reason to hit clear on your calculators. Just leave it there. It's not a big deal. I mean, if you hit clear, it's not a big deal either. But don't do a double step. Okay? Just leave it there. So, area is equal to, our apothem is 7 times our perimeter is 72.6, and we're going to divide that by 2. So now in your calculator, you have 72.6 times 7 divided by 2. Question? I didn't need to. I just did it. Okay. And I think the answer comes out to be 254.1 feet squared. Sweet. Shrink this a little. So area is equal to 254.1. Whoa. Okay. So number 2, bless you. Number 2, we have the side and we have the apothem. So what's the perimeter? So actually, Trinity, can you count up the sides for me on your paper? Just count them. Do we agree?
There's 8. There's 8.
Okay, so our n is 8. Okay. Okay. Gabe, what's our perimeter? Well, tell me the step to find the perimeter. Perfect. Do you know what that is yet, or did you put it in your calculator? 106.4. Okay. And so the area is going to be 16 times 106 point. Wow, that point should not be that high. 0.4 divided by 2. See, and this is where, you know, if you're somebody that's kind of like, oh my God, I don't like calculate, like I'm a little sketchy about my calculator. I don't really like to do multiplication with division and addition and all that stuff. Look, you could do this right here. Now you only have multiplication. It's behind you. It's right in front of you. Oh, I'm covering it. No, I'm not. Okay? That right there gets rid of the division. Okay? If you can see that, that might be helpful. So now all you have to do is 8 times the 106.4.
And that's the answer.
What is it? 851. 851.2 centimeters squared. I cannot stress this enough, you guys. If you forget that centimeters squared, you really will lose a point. Okay? And I'm sorry, but that's a silly thing to lose a point on. Those are gimme points. Okay? It really truly is a silly place to lose a point. It can make or break a B and an A. It really truly can. Just like a negative and a positive could truly break an A plus to an A. So please, please, please make sure you do that, okay? All right, so let's go down to this, okay? So looking at number 5, okay? We are only given to the apothem. That's all we're given. Now, my suggestion, if you notice that this is, the apothem's kind of pointing up, okay? My suggestion is either turn your paper so that the apothem is pointing down, okay? Or, like what I'm going to do right now is I'm going to take the apothem and go straight down. You don't have to, but I'm going to tell you, really? It is much easier when it, for some reason, if it's, you know, facing this way. I don't know why, but it just is. Maybe because that's how I've been taught all these years, but it is what it is. Okay. And then we need our radius. And that's going to go from there to there. Okay. And when we drop the apothem, we get a 90 degrees right here. And we need to find out what that angle is. Okay, we need to find out what that angle. Now, it actually is a lot easier than we think. Okay, so how many sides? 6. Okay. Here's how you do this. I know they said to do n minus 2 times 180. I know they said that. Okay, great. But that gives you these angles right here, right? That gives you the sum of the angles on the interior, right? That touch the outer. What are these angles if I was to figure out these? What is it? 360. Didn't I just make a circle? Yeah? Look, guys, look what happens. If I was to draw All of those. You don't have to do it, just watch. If I was to draw those, doesn't all of those add up to 360? Does that make sense to you guys? Yeah. So I drew all of my radii, I guess, right? And if I was to like hold a little string and I walked, or you're on the merry-go-round, right? And I walked around, right? Can I just make a 360, right? Makes sense, right? Okay. Why don't I just do 360 divided by how many sides? It's a regular polygon. Cool? Sure?
Sure.
Why not? You're looking at me like I'm crazy. I'm trying to give you the way out. All right, so 360. How many sides? 6. I get what? 60. Now, you still have to divide by 2. Because what did I do? I just found this entire triangle. Okay? The 60 goes to that entire angle. I only want, I don't know what color I want now. I only want this one. I only want half of that triangle's angle. Vertex, I should say. So I now have to take this and divide it by 2. What do I get? Can't you see? I'm in the way. Sorry. Nice job. Okay. Is there any questions up to this point? I really need you to ask because when I go from here, it's kind of the next step of the problem. If you don't understand this part, it's kind of like I'm done with the angle. I'm going to use the angle to get to the next step now. We're okay? Okay. The next step, I highly suggest you pulling the triangle out. It makes life so much easier. You don't have to make it large. You just pull out the triangle because it's so difficult to see inside this that it might be much easier if you just go like this. And you know that this is 30. You know this is a right angle, and you know this is 5. Everybody okay with me pulling that out? You guys got it? What part of that triangle do I need? Do I need the radius or do I need the side? Do I need this or do I need this? Here's the formula. We have the apothem. I need perimeter. Is this right here, which is this, going to help me find the perimeter? Is the radius going to help me find the perimeter?
Is AP quantum and perimeter?
Correct. Yes. Does the radius help me find the perimeter? No. So I need this guy right here. That's what I need. I need this. Ooh, that didn't work. This is what I need right here. Okay, if I find that, I find the perimeter. So I have to double it. Okay, we need to use our formulas. So across from the 30 is what? X. Okay. Okay. If I put my 60 in here, right? This is what? Across from the 60 is what? So this would be x rad 3. You have to equal it. This is going to be 5 equals x rad 3. Divide.
So is x equals,
Hold on.
5 over the square root of 3.
So this is going to be 5 over the square root of 3 equals x. Remember, you can't have the square root down there. I'm still writing. So you could do tan of 30 equals x over the number. So if that's the case, I'm going to cover up 4 for a second. If we cover the, if we were to do tangent, it would be tangent of 30 equals x over 5. So x would be 5 times tangent 30. But you have to understand, that's only half of the side. Okay? So this right here is only this part. Okay? If you're going to do that, which is totally fine, it's not a big deal, what you have to do is you have to do 2 times 5 tangent 30, which is what? Hello? No, 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 no. I don't want the answer like that. What? If you do 2 times the 5, it's going to give you the 10.
And then you 10, 10,
Are you on, what problem are you on?
Yeah, what do you?
3. Still on 3. I just covered up 4 for a second. So if it's 10, tan, 30, that's only one side. How many sides are there? 6, correct?
Wait, how'd you get x over 5?
Oh, I get what you did in the time.
Okay, you guys, please pay attention for a second, okay? If we're going to find out what this side is, we could do the tangent of 30, which would be x over 5. That's what I'm doing here. But you have to understand that it's only half that side, okay? You have to multiply it by 2 to get the full side. Once you do that, you get 10 tan 30. To find the perimeter, you would have to do 6 times the tan 30, which is perfectly fine. You don't have to deal with this rad 3. Might be a better way your mind might see it. So this would be 60 tan 30. There's your perimeter. Please, thank you. Okay, so your area, I need the space here at this point. So your area actually would look like your apothem, which is 5 times 60 tan 30 divided by 2. So what's 5 times 60? 300 tan 30 over 2. And that's more doable in your calculators than the rad 3. Okay? So if anything, you might want to get rid of this part and just do your sine, cosine, tangent. Okay, that might be something you might be okay with. These are all apophthegms. This answer right here is 363.5 inches squared. Sorry, I didn't give you this answer. This is 86.7. This one is 119.5. Okay, let me look at homework really quick, please. Okay, so homework 3 and homework 4